You probably believe you understand far more than you actually do. Not because you're unintelligent, but because your brain is very good at tricking you. It recognizes words, repeats explanations, and mistakes that familiarity for understanding. Richard Feynman warned that this illusion is one of the most dangerous habits of the human mind, because the moment you think you know, learning stops. Many people believe that learning begins and ends with knowing the correct name for something. If they can label a concept, repeat a definition, or recall a formula, they feel confident that they understand it. Richard Feynman strongly challenged this idea. He argued that naming something gives only the illusion of understanding, not the real thing. A child may know that a bird's movement is called flight, but that word explains nothing about how air pressure, wing shape, and motion interact to lift the bird off the ground. The label feels satisfying because it stops further questioning, but it does not reveal the mechanism behind the phenomenon. Feynman often illustrated this problem by pointing out how people confuse vocabulary with insight. When asked to explain how something works, they respond with technical terms instead of clear reasoning. These terms act like mental shortcuts, allowing the brain to feel knowledgeable without doing the hard work of thinking. The danger is that this type of knowledge cannot be transferred or adapted. If circumstances change or a new problem arises, memorized words offer no guidance. True understanding, on the other hand, allows a person to rebuild an idea from first principles and apply it flexibly to new situations. In science, this difference becomes especially important. A student might correctly recite Newton's laws or write down equations, yet fail to grasp what those laws actually describe about motion and forces in the real world. Feynman believed that such learning is fragile. It works only in familiar textbook examples and collapses when reality behaves differently. This fragility exposes the illusion. The person never understood the concept, only the symbols used to represent it. Feynman insisted that real understanding shows itself through explanation. If you truly understand an idea, you can describe it in plain language without hiding behind advanced terminology. This does not mean oversimplifying or losing accuracy, but revealing the logical structure beneath the words. When explanations fall apart during this process, it becomes clear that the knowledge was superficial. By separating naming from understanding, Feynman taught an essential lesson about learning itself. Knowledge is not about collecting terms, it is about building mental models that explain how the world works. Names are useful tools, but they are not the destination. When people mistake them for understanding, they stop learning too early. Recognizing this illusion is the first step toward deeper, more honest knowledge. The human mind has a powerful tendency to confuse familiarity with understanding, and Richard Feynman warned that this habit quietly shapes how people judge their own intelligence. When an idea is heard repeatedly, the brain becomes comfortable with it. That comfort feels like comprehension, even when no real reasoning has taken place. Over time, familiarity produces confidence, and confidence is often mistaken for knowledge. Feynman believed this mental shortcut is one of the main reasons people stop questioning ideas long before they truly understand them. This illusion is strengthened by repetition. Words, explanations, and concepts that appear again and again start to feel obvious. Because the mind recognizes them instantly, it assumes they must be understood. But recognition is not the same as comprehension. A person may recognize a sentence, a formula, or a theory and still be unable to explain why it is true or how it works. Feynman pointed out that the brain is easily fooled by this recognition effect, accepting mental ease as proof of understanding when it is actually a sign of habit. Education and society often reinforce this mistake. People who speak confidently using familiar language are seen as knowledgeable, even if their explanations lack depth. Meanwhile, those who hesitate, ask questions, or admit confusion are often judged as less intelligent. Feynman saw this as backward. He believed that the willingness to struggle with ideas, to feel confused, and to ask simple questions is a sign of real thinking, not weakness. The illusion of knowing thrives in environments where appearing smart matters more than being accurate. Familiarity also creates resistance to new information. Once an idea feels known, the mind becomes protective of it. Contradictory evidence is ignored or dismissed because it threatens the comfort of certainty. Feynman argued that this is dangerous, especially in science. Progress depends on questioning assumptions, not defending them. When familiarity is mistaken for truth, errors persist and understanding stagnates. Feynman's approach was to deliberately challenge this illusion. He treated every idea, no matter how familiar, as something that needed to earn its place through explanation and evidence. If an idea could not be rebuilt from basic reasoning, then it was not truly understood. This mindset required humility and patience, but it protected him from false confidence. By exposing the difference between familiarity and understanding, Feynman revealed a crucial insight about learning. Feeling comfortable with an idea does not mean you understand it. In fact, comfort can be a warning sign that curiosity has ended too soon. Real understanding often feels uncomfortable at first because it forces the mind to confront its own limits. Recognizing this difference is essential for anyone who wants to think clearly, learn deeply, and avoid being fooled by the ease of familiarity. Richard Feynman believed that true understanding reveals itself through simplicity. An idea that is genuinely understood can be explained clearly using plain language without relying on impressive words or complicated symbols. When explanations depend entirely on technical terminology, they often hide confusion rather than reveal insight. Feynman argued that complexity is frequently used as a shield, protecting fragile knowledge from being examined too closely. If a person truly understands a concept, they should be able to strip it down to its core and explain how it works step by step. This does not mean that complex ideas are simple in nature. Science often deals with phenomena that are subtle and mathematically precise. But Feynman made an important distinction between necessary complexity and unnecessary obscurity. Necessary complexity arises from the nature of the problem itself. Unnecessary obscurity comes from unclear thinking. When an explanation becomes vague or collapses during simplification, it exposes gaps in understanding. Those gaps are not failures, they are signals showing where learning must continue. Feynman often tested his own understanding by imagining that he had to teach an idea to someone with no background knowledge. This forced him to confront weaknesses in his thinking. If he reached a point where he could not explain why something happened, he knew that memorization had replaced understanding. This habit of self-testing kept his knowledge flexible and alive, rather than rigid and dependent on formulas. Simplification also reveals whether an idea can survive outside of familiar contexts. A concept that is truly understood can be applied in new situations, explained through analogies, and connected to everyday experience. If understanding exists only within a narrow set of examples, it is likely incomplete. Feynman believed that the power of understanding lies in its ability to travel, to adapt, and to illuminate unfamiliar problems. Many people fear simplifying ideas because they worry about sounding ignorant or losing precision. Feynman rejected this fear. He believed that clarity is a form of respect for truth. An explanation that cannot be made clear is not yet finished. Simplifying is not about lowering standards, it is about sharpening them. Each step toward clarity removes confusion and brings the idea closer to reality. Through this principle, Feynman taught that understanding is not proven by how complicated an explanation sounds, but by how clearly it reveals cause and effect. When an idea remains coherent under simplification, it shows strength. When it collapses, it exposes illusion. Learning, in Feynman's view, is the process of pushing ideas through this test again and again until only real understanding remains. Modern education often creates the illusion of learning by rewarding students for giving correct answers rather than for developing real understanding. Richard Feynman criticized this approach because it trains the mind to focus on outcomes instead of reasoning. Students quickly learn that success comes from memorizing definitions, formulas, and procedures that will appear on exams. Over time, learning becomes a performance rather than an exploration. The goal shifts from understanding how things work to simply producing answers that satisfy the system. This structure encourages shallow knowledge. When students are judged primarily by test scores, they naturally optimize for recall instead of comprehension. Feynman observed that many students could solve problems by following steps without knowing why those steps worked. Their knowledge functioned only within the narrow boundaries of familiar questions. When faced with a slightly different problem, their confidence vanished. This revealed that they had learned methods, not ideas. Feynman believed this problem was especially harmful in science education. Science is not a collection of facts, it is a way of thinking about the world. But when teaching focuses on memorization, students miss the deeper lesson of how scientific knowledge is built. They are rarely encouraged to question assumptions, test ideas, or explore uncertainty. Instead, they are trained to accept information as finished and authoritative. This suppresses curiosity, which Feynman saw as the engine of discovery. The pressure to appear competent also discourages students from admitting confusion. In classrooms, not knowing the answer often feels like failure. As a result, students hide their misunderstandings instead of confronting them. Feynman argued that this is backwards. Confusion is not a weakness, it is a sign that the mind is actively engaging with a problem. When confusion is avoided, learning becomes passive and fragile. Teachers are not always to blame. Feynman recognized that educational systems are shaped by efficiency, standardization, and large-scale testing. These systems make it easier to measure answers than understanding. But the cost is high. Students may graduate with degrees, yet lack the ability to reason independently or explain ideas clearly. They know what to say, but not why it is true. Feynman's criticism was not meant to reject education, but to reform its purpose. He believed that learning should train people to think, not just to remember. Education should cultivate the habit of questioning, the courage to say, I don't know, and the skill of building ideas from basic principles. Without these, schooling risks producing confident repetition instead of genuine understanding, reinforcing the illusion of knowing rather than breaking it. Overconfidence, Richard Feynman warned, is one of the greatest enemies of science because it convinces people that questioning is no longer necessary. When individuals believe they already understand a subject completely, they stop testing their ideas against reality. This false certainty creates the illusion of control, but it also blinds the mind to errors. In science, where progress depends on constant correction, overconfidence can be disastrous. Feynman believed that many serious mistakes do not come from ignorance, but from the belief that one is no longer ignorant. The illusion of knowing feeds overconfidence. When people mistake memorized information or familiar explanations for real understanding, they feel justified in their certainty. This confidence often goes unchallenged, especially when it is supported by authority, credentials, or consensus. Feynman distrusted such certainty. He argued that no idea, no matter how widely accepted, should be immune to doubt. Nature, not reputation, decides what is true. In scientific history, Feynman saw repeated examples of progress being delayed because confident experts dismissed inconvenient data. When assumptions are treated as facts, anomalies are ignored rather than investigated. Over time, these ignored details accumulate into failures. Feynman emphasized that science advances not by defending beliefs, but by attacking them, actively trying to prove them wrong. Overconfidence reverses this process, turning science into belief instead of inquiry. The danger of overconfidence is not limited to laboratories. It influences engineering, medicine, politics, and everyday decisions. Feynman famously demonstrated this during the Challenger disaster investigation. Engineers relied on complex reports and assurances, convinced their understanding was sufficient. Feynman approached the problem differently. He tested the physical behavior of the O-ring directly, showing how reality contradicted confident predictions. The failure was not due to lack of information, but to overconfidence in flawed assumptions. Feynman believed humility was essential for real understanding. This did not mean doubting everything endlessly, but recognizing that knowledge is always incomplete. Science, in his view, is a method for managing uncertainty, not eliminating it. Overconfidence pretends uncertainty does not exist. Humility accepts it and works within it. By exposing overconfidence as a threat, Feynman taught a crucial lesson about thinking itself. The moment someone feels absolutely certain, learning stops. Errors become invisible. Real understanding requires the courage to remain uncertain, to test ideas relentlessly, and to accept correction without ego. Science survives because it allows itself to be wrong. Overconfidence threatens that survival by replacing curiosity with certainty and inquiry with belief, reinforcing the illusion of knowing rather than revealing the truth. Richard Feynman believed that admitting ignorance is not a weakness, but the foundation of all genuine learning. Many people fear saying, "Don't know," because it feels like failure or embarrassment. Society often rewards confidence and quick answers, even when they are incorrect, and this pressure encourages people to hide uncertainty. Feynman rejected this mindset completely. To him, the honest recognition of ignorance was a powerful and necessary step toward understanding. Without it, curiosity has no place to grow. Feynman argued that pretending to know blocks learning more effectively than ignorance itself. When someone believes they already understand a subject, the mind closes off to new questions and evidence. In contrast, admitting ignorance keeps the mind open. It creates space for exploration, experimentation, and revision. Feynman was comfortable living with unanswered questions because he saw uncertainty as a natural part of science. The world is complex, and expecting complete certainty is unrealistic. Learning, therefore, begins not with answers, but with honest questions. This attitude shaped Feynman's approach to science and life. He regularly challenged his own assumptions and enjoyed discovering where his understanding failed. Each failure was an opportunity to think more deeply. Instead of protecting his ego, he protected the truth. Feynman believed that progress depends on this willingness to be wrong. Every scientific discovery, he argued, is built on previous misunderstandings that were openly acknowledged and corrected. Admitting ignorance also strengthens critical thinking. When people accept that they do not know everything, they become more careful with claims and more attentive to evidence. They listen better, ask better questions, and test ideas more rigorously. Feynman believed that this habit protects against deception, including self-deception. He famously warned that the easiest person to fool is oneself. Saying "I don't know" is a defense against that trap. In education, Feynman saw the refusal to admit ignorance as a major obstacle. Students are often trained to hide confusion rather than explore it. This creates fragile knowledge built on guesswork and memorization. Feynman argued that teachers should encourage uncertainty, not punish it. Confusion signals that the mind is reaching beyond its current limits. Supporting that moment is essential for real learning. By elevating ignorance to a virtue, Feynman redefined intelligence itself. Intelligence was not about always having answers, but about being honest with what you do not understand and having the courage to pursue it. The admission of ignorance marks the starting point of discovery. Without it, knowledge becomes rigid and false. With it, learning remains alive, flexible, and grounded in reality, breaking the illusion of knowing and replacing it with genuine understanding.